quick video here to wrap up the second day of this section. We're going to apply some linear functions. So it says Tamika records the outside temperature at 6 a.m. and the temperature increases 2 degrees every hour for the next 6 hours. If it continues to increase the same rate, what will the temperature be at 2 p.m.? So if you notice real close here, and it also says it over here, we are starting at a -3. So my x represents hours. My y represents the temp. So we started at -3. I'm sorry. That's not right. Go back here. Sorry. Erase here. Yes, we started at 0 hours. I just said this was 0 hours because really that's 6 a.m. But that's 0 hours for what we're trying to figure out here. And if you look at this XY axis, how they set it up, we have 0 and a temp of -3. So then from 6 a.m. to 2 p.m., how many hours would that be? Well, we could do a couple of them. We know at 10 o'clock that would be 4 hours later. How many would it increase by? Well, it would increase from here to here. It would increase 4 times 2. It would increase by 8. But over here we're at -3. So now we're at 5. Let's see, does that look about right? Well, sure, 4, 5. Yeah, that matches our graph. And then by 2 p.m., the question, that's 8 hours later. So that would go up another 8 degrees. And so that would put you at 13. So in a span of 8 hours, you went up 16 degrees. So you didn't necessarily need this point, but what will the temperature be at 2 p.m.? It'll be 13 degrees. There's your answer. And that matches up. It supports our graph. So we just know that we did the formula. If we wanted to write an equation here, we're going up 2 degrees, but we started at -3. That's my y-intercept. Down here it asks, does the linear function realistically represent the temperature for the domain 0 to 24? So if we think about a temperature throughout the day, it goes up, it goes up, it goes up, and we get to the afternoon, and then dinner time it starts to cool off. Is that a line? This is not a line, this is curved. So does it work for 0 to 24 hours? No. Temp decreases at night. And it increases, so you could just do an up arrow here, during most of the day. So that's not our linear line. It decreases sometimes, and it increases others. It says sketch the graph of each function. In order to sketch a graph, here's what I would recommend that we do. We need to pick some points that are spread out on the graph. We don't want to do, so don't write this down. If I do my x and y, we wouldn't want to do something as simple as 1, 2, 3. Because that's kind of hard to sketch a line that goes through the entire graph. Instead, if I let all of these equal 1, looks like we got 2, 4, 6, 7. So we could do like -5, 0, and 5. So if I put in -5 into here, the opposite of -5 because that's what this negative tells us to do. It's positive 5 plus 1 is 6. And then 0, so negative 0 plus 1 is 1. And then 5, the opposite of 5, so we're at negative 5 plus 1 is negative 4. So you could use your calculator for those if you need to. That's fine. On a test, I would recommend it. So I have 3 points. Here we go. I go back 2, 4. There's my negative 5. And I go up 2, 4, 6. Put a dot. We're at 0, 1. I go 2, 4, 5. And we're down 4. Now on here, I believe I can draw a line. So let's see if I can pull that off. So I can just drag a line, and of course my sketch then is really accurate. If you're not using the Cami app like I am, it may not be as accurate, and that's okay. So over here, same thing. I would do 3 points spread out. Might as well just keep with this negative 5, 0, and 5. So there's my x, here's my y. So I plug in negative 5. Negative 5 times 15 plus 2 is negative 13. That's a problem, because that doesn't fit on here unless we change it to a different scale. So over here, we did a scale of 1. Here we could do a scale of 2. So now we got negative 2, negative 4. So I'd be at negative 5. Now we'll go down negative 2, 4, 6, 8, 10, 12, 13. So I'd be right here in the middle of this square. If I'm at 0, I'm at 0, positive 2. So that would go up right to there. And of course, if I'm at 5, 5 times 3 is 15, plus 2 is 17. So now I gotta go over here, 2, 4, 5, and go up 17. The problem is that's gonna go slightly off my grid. 2, 4, 6, 8, 10, 12, 14. So 16 would be right about there. So we'll make 17 there. And again, these are sketches, but I do have this, so draw a line all the way through it. Doesn't have to be perfect, but that's a reasonable sketch. That's what you need to do today. Everything on this worksheet needs to be done. We did 1 through 7 yesterday. You should have done 1 through 12 as in your homework. So now, our new assignment is not 1 through 12. It's 1 through 20. Yesterday you did 1 through 12, so you're only adding 8 problems. I'm going to go down here. Some of these ones here are multiple choice. These PSAT ones, take your best guess on them. There may not be a lot of work to show on just 15 and 16, 17 and 18. 17 and 18, you might have to do some work, but the other ones up here, just some quick multiple choice, take your best guess. This is a multi-step problem. We should have already done these. I'm going back here, and then I'll wrap this up. All of these have a 0. So I could make this really, really simple, because as we went up 1, it went down 8. So that's my slope, negative 8 over 1, negative 8. So we just do y equals negative 8x. And there's my y-intercept, plus 16. Problem is, on a test or quiz, the 0 won't always be on here. So I think you would be wise to use point slope form on at least 2 of them. Make sure you know how to do point slope form. And that is all for today.